Hi guys, welcome to again to my channel. My name is Malasa. Today I'm gonna be showing you the detailed logic combination as per the Ethiopian building code of standard and the European building code of standard. Actually, I have already shown you the detailed logic combination in tutorial part 13. But some of the guys requested me that will be better if I prepare a separate tutorial with reference to the logic combinations because some are confused with some logic combinations apart. So that is why just I am preparing these tutorials with reference to the logic combinations. So if you are a new member for this channel, don't forget subscribe my channel. And also if you are a member of my channel, don't forget just like and share my video to your friends so that your friends will be getting more relevant tutorials which have been already prepared with reference to this journey story building. So if you wanted to get also a new an immediate notification for a newly uploaded video, you can press the bell icon. And also, if you have any questions regarding to the structural designing works of the reinforced concrete as well as steel structures, don't hesitate to put your questions and comments in my commenting box so that I will try to answer your questions within a short period of time. So this is the continuity tutorial parts, which is the continuity parts of tutorial part 13. So this is tutorial part 13b, and the previous one is the tutorial part 13a, which will be focusing on the detailed logic combinations part. So now let's start. Here the logic combination, meaning that now let me clarify logic combination. So we'll have two type of load combination. The first one is the the fundamental load combination, and the second one is the seismic or accidental or seismic load combination. Accidental or seismic load combination. In the case of fundamental load combination, here we will not consider seismic in this case. So the basic and the fundamental loads will be gravity plus variable load. Variable load. So those variable loads may be wind or temperature or snow. That means it may be wind or it may be temperature or it may be snow or it may be rain. And there is also flood live load. So how many variable loads are there? 1, 2, 3, 4, 5. And if there will be uh, other variable load, just we can add up to this variable load. And in the case of seismic combination, that means the gravity load plus this is the permanent load. It is not the gravity load, rather it is the permanent load. And here in this case also the permanent load plus the earth cube load, that is AD. Here, in the case of variable load, you know this is the floor live load. So in the case of accidental or in the case of seismic combination, we'll consider the permanent load, the floor live load, and the earthquake load. And in the case of fundamental load combination, we will consider the permanent load and the variable load. So having all this in mind, the Ethiopian Building Code of Standard and the European Building Code of Standard uh, just recommends us to use the as either the seismic combination in the case of seismic condition, and we can use the fundamental load combination where there is no any seismic action. So in the case of fundamental load combination, the primary loads are the permanent loads and the variable loads. So now let's proceed to the code. Here, this is the Ethiopian Building Code of Standard. So, in Ethiopian Building Code of Standard, which is a similar version of the Eurocode, it will have the combination, which is combination 6.1 and combination 6.1a and combination 6.1b. So, all those combinations, all those combinations involves the floor live load and other accompanying variable load and the permanent load and the pre-stressed load. So this is 6.1. So taking into account this combination, that is 6.1 combination, let's proceed to, we can only minimize it. That is by considering the fundamental combination. So here for ultimate limit state, that is gamma, that is the partial factor, the combination factor for dead load plus gamma for the variable action, which is the leading action. It may be leading plus the other variable load. This is 1 and it may be 2. So this may be the combined effect of other variable load. And this is the general combination for 6.1. So from this we can just extract different combinations. So here in the case of this one, we can take weight. And in the case of this one, we can take floor live load. Or when the floor live load is leading, then the wind will be accompanying. Because both of them will not come at the same time. So the one which comes first can be regarded as the leading variable load. Now here gamma, so we can take gamma as 1.35. So the first combination will be, that is we are considering 6.1. That means the fundamental combination. So here it is 1.35, the permanent load, plus 1.5, the live load, that is the floor live load, plus As it is the leading one, we will not multiply it with phi. Here we have phi 0 here, and will not multiply the variable with a reduction factor phi 0 because it is the leading one. So plus phi is, it is 1.5 multiplied with, phi 0 is, it is 0.7 for all the building. That is, except for wind. That is 0.7 times, that is wind in I direction. So here this is for the condition where there is no any seismic action. This is the first combination, and now we can say this I as x positive. We can say it as x positive direction, and also 1.35 permanent load plus. Now here this is the in the first equation, the floor live load is the leading variable load. But in the case of in the second equation, this will be accompanying one. So when it is an accompanying one, it becomes 1.5 times, that is phi 0, which is 0.7 cube plus. So this becomes what? It becomes the leading one. So 1.5 times wind in x positive direction. And the second combination will be 1.35 permanent load plus 1.5, this becomes the leading one, 1.5 q minus 1.5, that means in x negative direction, times 0.7 in x negative direction, and also 1.35, so that means it becomes in negative direction, that is permanent load plus 1.5 into 0.7 plus 1.5, sorry, this becomes minus because we are applying in negative x direction, minus 1.5 times wind in x negative direction. This is for the combination in x direction by considering the floor live load and the wind load will be the leading variable loads. And also when we consider the y direction, that is 1.35, that is just changing wx to wy, 1.35 g plus 1.5 q1 plus 1.5 into 0.7. Okay, this one 1.5, and this one is, it is 0.6. Sorry, this one is what? It is 0.6, and this one is, it is 0.6, and this one is 0.7 because it can be taken from the code. The phi value for wind is, it is 0.6 for wind, and the phi value for variable load, it is 0.7. So phi 0 for live load, it is 0.7, and phi for wind, it is 0.6. How it comes? Just to go to the Ethiopian building code of standard, just here. No, 50 it is for wind it is 0.6, for temperature 0.6, for wind it is 0.6, and that is 50 for other floor live load can be taken 0.7 except for garage. So this is 0.6 times the wind in y at positive direction, and the other 1.35 times the permanent load plus 1.5 multiplied with the combination factor, that is the reduction factor 0.7 times q plus 1.5, that's in negative direction, I can make it, that is minus 1.5. Okay, this is x minus, this is y plus okay, yeah, I can make it plus sign plus 1.5 times wind in y positive direction, and the other 1.35 times the permanent load plus 1.5, that is the third one, this one, times the variable load minus 1.5 multiplied with 0.6 times the wind in y negative direction, this one, and the other 1.35 times the permanent load plus 1.5, that is the first one, first one, 1, 2, 3, 4, 1.5 times 0.7, 0.7 minus 1.5 with 0.6 in y negative direction, that is wind y negative direction. Okay, now this is the leading one, so we need not multiply it with reduction factor because we have already applied a reduction factor for a combining action of floor live load. So how many combinations are there? 1, 2, 3, 4, 5, 6, 7, 8 load combination which involves the permanent load, the floor live load, and the wind loads are generated here. And the other is we can put also the gravity load combination, that means 1.35 permanent load plus also 1.35 permanent load, one of the combination, and the other is 1.35 permanent load plus 1.5 live load. So this is all the combinations that involves in a building. So how many combinations are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 combinations can be incorporated in our structures. So this is for the case where there is no any seismic action. What about if there is the seismic action? Now, the basic and the fundamental one is this one, because our structure is located in seismic condition. So, here, seismic combination. Now, seismic combination. So, in the case of seismic combination, so here our code recommends us to use the uh, This is the basic combination. So even we can use this combination, but mostly the governing one is that is 6.1 for non-seismic condition. So this is the governing one. So we can use this 6.1b can be used just where the condition is a reduction of the permanent loads. That means the permanent load will be reduced by some factor. That means the Ethiopian Building Code of Standard recommends to use 0. I think 92. That is 5 value. 0 0.8, 0 0.9. So the ETABS incorporates, that is by default a combination of 6.1. So we can take this combination, which is 6.1. The seismic, the other is, the seismic combination, this one. This is the seismic combination. Most of the civil engineers are being confused with the seismic design load combination. So when we say the seismic design combination, this is an the combination which will be considered during the design of the structure where it is when it is located in seismic region. That means this is the ultimate limit state. For ultimate limit state, design situation meaning is that for ultimate limit state. So when we come to the combination that is 6.1 to A, or all the loads that will be incorporated in seismic design situations are the permanent load, the pre-stressed load, the earthquake load, and the variable load. So when we split this one, just we can put just like this. That means the permanent load combined with the pre-stressed load combined with the earthquake load combined with this phi 2 q k. That means the reduced variable loads. So here phi 2 that means the live load reduction factor will be considered during the preparation of the ultimate load combination for seismic situations. That means, so when we just put this one in detail, just it looks like this one. That means the sorry plus the earthquake load. That means earthquake EQ plus this one is plus or minus because it may be in positive and in negative direction. Plus psi 2 variable load QI. This is the seismic load combination for ultimate limit state. So when we just split, when we put this in details, that means in G plus one of the combination will be G, that is the permanent load, plus that means EQ X plus uh, EQ Y, that is 0.3 here. That means 30% of the seismic load in Y positive direction plus psi 2 Q. Here, this is basically floor live load. It may be floor live load or it may be roof live load or it may be vehicle live load. So this is the combined effect of all the variable loads. So just we can put just like this. But phi 2 may be variable. For floor live load, it will be taken 0.3. For for roof live load also 0.3, so we can put just like this. So it can be taken 0.3 for all variable loads. Uh, and this is one of the combination. And the second combination will be that is the variable, the permanent load uh, plus 100% of the earth cube load in x positive direction will be combined with that is the 30% of the earth cube load, in y direction plus this one. And the third one is the permanent load plus the permanent load plus the permanent load minus 100% of the earth's cube load in negative x direction combined with 30% of the earth's cube load in y positive direction plus this combination. And the fourth one is the variable, the permanent load combined with 100% of the earth's cube load in negative x direction and combined with the 30% of the earth's cube load in y direction, in negative y direction. And the other here, this is when 100% of the seismic load is acting on positive and negative x direction. And also there will be a combination where 100% of the seismic load will be acting along the y direction. So that is the permanent load plus the earth cube load in that is in y direction. This is y direction positive plus 0.3 earth cube load in x positive direction. And the other, the permanent load combined with 100% of the earth cube load acting in positive y direction, which will be combined with that is 30% of the earth cube load, which will be acting in x negative direction. And the other, the gravity load, I mean the permanent load, combined with the permanent load combined with that is 100% of the earth cube load, which will be acting in y negative direction, inter combined with the combined with this one is for y combined with the earth cube load, which will be acting on positive x direction. I mean the positive x direction. So this one is positive minus positive, and this becomes 0.3, that is AQ x positive direction. So okay, this is the permanent load with 100% of the earth cube load in y direction, 100% of the earth cube load in y direction with the negative x, 30% of the negative x direction. So this is negative, positive, and this one is this is in negative x direction. So permanent load combined with the earth cube load in y negative direction. So how many combinations are there? 1, 2, 3, 4, 5, 6, 7, 8 combinations will be required for seismic design. And here this is phi to qi, is it is the same for all the load combinations. So here, some of the guys are confused with the service load for seismic and service load for normal combinations. So when I say, service load for seismic and service load and live load for service. So in the case of this one, simply I collected all the gravity loads. That means I collected all the permanent loads. That means G and combined with the variable loads. That means Q, but the variable load must be reduced by a reduction factor, that is psi 2. So this is what we call the service load for seismic. And for the live load for service means just the live loads are collected together, meaning which is that is Q1 plus Q2 plus Q7 etc. That is all the variable loads are collected together and defined as a load cases, which is called the live load for services. Now let's see it in detail, because this is for gravity combination. This variable load will be used for gravity combination. And this one is for seismic combination. And this is only the variable load. And also the service load for normal combination, service load for gravity combination will be here. In this case, I am using the reduction factor, but in the case of gravity combination, I will not be using phi 2. So instead, it becomes the permanent load plus the variable load. So the factor will be 1. This is the service load for gravity combination. Now let me show you one by one in the model. So now let me say something about also the response spectrum here. This is for the linear static case, and for a response spectrum, just the procedures are similar to what we are following during the load combinations in the case of linear static. So just simply we can say EQX are that EQX, that is response spectrum, RS X plus. Just simply EQ can be replaced by R in the case of response spectrum. So for a response spectrum, that is, we'll have 8 combination for linear static load cases. We have 8 combination, and here we have the normal gravity combination. So that is 2 combination, normal gravity combination. We'll have 2 combination totally. How many combinations are there? Which is 18 combination. But this is for seismic case. This is for seismic case. So here in the case of wind, in the case of normal combination, I have already shown you the number of load combinations, and in the case of seismic load combinations, I just will have the total number of 80 load combinations. So now let me show or use the some pointers that should be taken into account while combining the load. Actually, I have already told you that we need to avoid redundancy of the load combinations that will create a longer time of analysis for ETABS and the logic combination that will not be adding any values to the structural analysis and the design here. Uh, some guys said that 32 linear static or equivalent lateral force analysis load combinations are required, and 32 this is for the equivalent lateral force uh, analysis. That means the linear static for linear static case they said that 32 combinations are required, and also similarly 32 load combinations will be required for the response spectrum analysis. But this is the one which we need to correct while combining the logic combination because they added an extra two logic combination for every axis by considering the centricity from the center of mass, meaning that they said and they designate the linear static or the RZ cube forces by that is RZ cube x top from the center of the mass, and that is in positive direction, and the other is that with the RZ cube load in x direction, that is in the bottom, which is in the positive uh, direction. And also similarly in negative direction, they designated that is RZ cube in x direction top, that means from the top of the center of mass, and in negative direction. And similarly in the bottom parts of the x negative direction, in this direction with the negative eccentricity, just they designate like this. And similarly in the y direction here, that is RZ cube in y direction, that is left of the center of mass in positive direction, and on the right side also, that is RZ cube in y direction, that is on the right side of the center of mass along the positive direction, and similarly in opposite direction, that is in the negative direction. When we combine this load, this creates that is we'll have four combination forces, and here for this we'll have four combination, and for this we'll have four combination, and for this will be required as they said. And similarly in this way also, that is 42 combination for this, and for this, and for this, and for this. So totally how many combinations are required? 32 combinations. In a response spectrum also, they were using a 32 combination, and for linear static case, they were using 32 combination, but it is a redundancy. And I tried to analyze 32 combination for linear static and 32 combination for a response spectrum. Yes, and I have got the results, and the results show that there is no any difference in results for this case and for this case, and even for this case and for this case. This is, as I said before, the opposite of this one, and this one is it is the opposite of this one. So that is enough to consider, which is one that is two direction for x direction, and two direction for the y direction. That means for one positive and for one negative case. So every direction will need two combination. So totally we'll have the 8 combination for linear static case and 8 combination for responses the y direction, and totally we'll have 16 load combinations for the linear static cases and response spectrum load cases. So I will try to show you. Just I have already analyzed it. So now let me show you the results here. Just you can see the load combinations here. Just I have analyzed by, that is here 32 combination, just by saying EQXB negative, EQXB negative, EQXB. This will be combined with the 30% of the respective RGQ plate, which will be coming in Y direction. So in Y left and right, in negative and positive direction. So every totally will have, I will not go in depth for every combination, but 32 combinations are combined here. And also for a response spectrum load cases, just 32 load combinations are combined here, and I have analyzed the model and I have got the results. So the results concludes that just we can go to the table and the results, and that is the base reactions here, base reaction. So here this let me maximize it. Here, the load cases, which is the load combination for the linear static or equivalent lateral force case is selected, that is 32 combination. And now the basic point is just to see the results. So we can see the fx, which is the meaning fx means that is the reaction for in x direction, which is both in negative and in positive direction. So here the negative sign indicator that the reaction along negative x direction, and the positive sign indicator that the reaction along the positive direction. So here just I can zoom it here. This is for positive direction. That means EQXB positive, meaning it will have this one. This is Fx, that is in positive direction. That is the reaction will be 311,218 kilonewton. That is the along the positive direction. This reaction, which is R reaction X positive. And when we come to also the that is the EQXB bottom, that means the negative along the negative direction, and this one is also, that is EQX bottom means which is just you can this one. This is the center of mass, and we are just discussing about the reaction which will be generated due to the RGQ cloud, which will be acting along the positive x direction at the top and at the bottom. Here, this one is at the top, and this will be at the bottom. Here, this is a center of mass, and this is the eccentricity. So, in negative, so this one is along x negative direction. This one along x negative direction, and this one is x positive direction. But what is the difference at the top and at the bottom? So here, this negative sign indicated that the RZQ cloud, which will be acting along the negative direction, will create this much amount of what? Reaction force. So that is EQXB positive. So EQXB positive, that will be combined with the RZQ cloud, which will be coming along the y direction with 30% in proportion. And so here you can see the result here. All are the same, just except that is opposite inside. You can see this one. Here all are just the same results. Here just you can see. Just you can see it. So this indicated that the earthquake load which will be acting along the positive x direction and the negative x direction will be the same in magnitude but opposite in sign. So no need of just using more combination along in x direction because it will not add any value or results. So that is why that is enough to consider that is EQ x in positive direction and that is EQ x in negative direction. And this eccentricity will considered by ETABS automatically for linear static case as well as for dynamic case, that is the response spectral cases. So this is for the case here. Just we can see that is the EQY here. That's EQX top, EQX, 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 EQX. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is totally, which is 32 combinations. And when we come to also in the y direction here, EQY. So here just you can see this. This is for y direction. And the above were for x direction. For y direction is similar. That is the results are what? The results are, it is similar. 3, 1, 1, 1, 8, 8. Now let me zoom it. So you can see it. This is 8, 8. This is 1, 8, 1, 8, 1, 8, 1, 8, 1, 8, 1, 8, 1, 8. And this is what? The second result. Sorry. Here, 3, 1, 1, 8, 8. But the above are 2, 1, 8, 2, 1, 8. This one is 1, 8, 8. And this is what? The second result for y direction. So, one result for x direction and one result for y direction. But two results with the same in magnitude. And four results with this much, 3, 1, 1, 1, 8, 8 for y direction. One result for positive direction and one result for negative direction. That is, the negative direction will take the negative side and the positive direction will take the positive side. So totally we'll have four results. The rest are redundancy for results. But from four results, that is two similar magnitude. Two results with similar magnitude. But when we consider the negative sign, we'll have totally four results. But when we consider the magnitude only, we'll have two results. So this concludes that the considering the response spectrum load combination and just considering the earthquake, that is the linear static load combination in x positive and in x negative direction as well as in y positive and y negative directions are adequate enough. So we need to avoid the repetitive load combinations of the linear static cases and response spectrum load cases. So this is what I am going to what I wanted to show you and what we are going to take into our consideration during the load combinations. Okay, now let me come back to ETABS. Just go to the define menu. So here, the define menu, and then here the load cases. Now let me clarify you something about the load cases. Here, so now consider, now go to the define menu, the load combination. Here we have the normal load combination, that is 1.35 permanent load plus 1.5 the variable load, and the other is the combination that I have already defined, that is 8 combination 1, 2, 3, 4, 5, 6, 7, 8 combination for linear static, and 1, 2, 3, 4, 5, 6, 7, 8 for response spectral analysis. So the service load for seismic meaning, now the service load for seismic meaning, so that is the permanent load for service using a factor 1, because all the permanent loads will be multiplied with 1 for service, meaning the summation of Q plus the summation of, sorry, this means it is the summation of permanent load, this one. And the live load for seismic meaning, this one, plus, when we take this one, the live load for seismic meaning, that is phi 2 times Q. Phi 2 times Q, this one. That means the reduction factor phi 2 multiplied with the variable loads. When we come back to this load cases, that means permanent load for service and live load for seismic one. So first, now let me show you permanent load for service. Now come back to the load cases. Just go to the define menu. In load cases, here the live load for seismic and the permanent load for service. Now modify. This is permanent load for service. Here permanent load service, that means the summation of all gravity loads with reference to permanent load. This is the summation of all permanent loads. Just I have already taken 100% of the permanent gravity loads. That is why that is permanent load for service. Name is provided for this one. And the other is the live load for seismic. That is modify the live load for seismic. This means the summation of the phi 2 times the variable load. That means the live load for seismic one. This is what you call it is the live load for seismic one. Meaning the variable load will be multiplied with some reduction factor, because we are going to apply the variable load for seismic combination. So here all this here all those are the combination factor, that is phi 2. Here except we are using 0.6 for category C, that is conjection area. Actually category C is not applied for our building. If you apply, that is the congestion live load, then automatically 0.6 will be applied as a reduction factor. So for my case, phi 2 equals to 0.3 for all variable loads. That means I have applied 3 variable loads: floor live load, live load at roof, and live load for parking. For both of those 3 load types, I can use a reduction factor, that is 0.7. Okay, this is for live load for seismic one. And the other is the live load for, live load for service one. The live load for service one. And this one is also here. The live load for service one. This is also the summation of variable load for service. So here we should not use the reduction factor. Phi 2 should not be used here because this live load will be used for the combination of gravity loads. That is why I am excluding phi 2. So all the factors are 1. It is not 0.3. 0.3 is not used here. That is 100% of the variable loads are taken into account. Okay. So I think this is all about the clarification of the load combinations of this theory, the story, building as per the Ethiopian building code of standard as well as the European building code of standard. So if you like my video, don't forget sharing my videos to your friends so that your friends will be getting more relevant tutorials which have been already prepared with reference to this journey story building. And also if you are a new comer for this channel, just try to subscribe my channel so that you will be getting lots of tutorials that I have already prepared with reference to this tuning story building. And also if you want to receive an immediate notification for a newly uploaded videos, just you can press the bell icon. And don't forget also providing me comments and questions regarding to the structural design works of the reinforced concrete structure as well as the structures in box so that I will try to answer your questions as much as possible within a short period of time. So this is all about for today's tutorial. See you next time with another very interesting tutorials. Bye bye.